Besides learning how to draw Lewis structure and to show like how the atoms are connected in a compound, we're going to use the Lewis structure to predict the shape of a molecule. So to predict the shape of a molecule, we base our possible shape in this specific theory here. The valence shell electron pair repulsion theory, which tells us that your electrons, they're going to arrange around the central atom in a way that allows them to avoid repulsions. Electrons are negative charges, so if they are too close, each pair of electrons, if they get too close, then they're going to repel. So they're going to use the space that they have available in a specific way to minimize those possible repulsions between them. So to determine the shape of a molecule, we do something really simple. We're going to be counting electron groups, okay? Electron groups around the central atom. And then we have what we classify as electron group listed right here. If you have a single bond, double bond, triple bond, or a lone pair of electrons, each one counts as one electron group. So even if you have a triple bond, that triple bond is still counted as one, just one electron group, not three. Your triple bond is shared between two atoms in your compound or in your Lewis structure. So it's shared in the same space between those two specific atoms. So it's counted as just one electron group. We have two different types of geometries. For the electron geometry, we're just counting how many electron groups you have around the central atom, and we're going to have 5 basic shapes. And then for the molecular geometry, we're going to distinguish between your total number of groups. Out of the total number of electron groups, you're going to have some of them that are bonding. If you have single, double, or triple bond, those are bonding groups. And your non-bonding, which are your lone pairs of electrons. So your 5 basic shapes, we're going to have some modifications whenever we have lone pairs of electrons around the central atom. So in this table right here, I have listed our 5 basic shapes, 1, 2, 3, 4, and 5. And then we have the 2 types of geometries, the electron geometry with the 5 basic shapes, and then we have the molecular geometry, which is when we have a modification based on how many lone pairs of electrons you have around the central atom. Okay? So you're going to be using the table and Lewis structures and counting how many electron groups you have around the central to determine the geometry. So I'm going to start with my CH4 here, that you already have the Lewis structure. So I'm going to mark the electron groups. I have a single bond, that's 1 electron group, that's another one, and another one. So I have a total of 4 electron groups around the carbon, which is the central atom. 4 electron groups, so I'm going to move here in my table where I have my total number of electron groups in the first column, right here, 4. Out of my 4 electron groups, there's no lone pairs or non-bonding pairs. All of them are single bonds, which means that you have all bonding pairs of electrons around the central. So all bonding, 0 non-bonding, and here you have your electron geometry. It's going to be tetrahedral. Whenever the number of bonding or non-bonding pairs is 0, it means that your electron geometry and your molecular geometry is exactly the same. You're going to get a different shape as the number of non-bonding electrons start changing from 0 to 1, 2, or 3 non-bonding pairs. Okay? If you have 0 non-bonding, then your 2 geometries are exactly the same. So for CH4, I have 4 and 0, and for both geometries you should have tetrahedron. NH4, I have 1, 2, 3, 4 electron groups around nitrogen, 4 electron groups around nitrogen, 0 non-bonding electrons. That's again tetrahedral for both geometries. NH3, I have 1, 2, 3 single bonds. Each one counts as one electron group, and I have one lone pair of electrons right there, which is counted also as one electron group. So for NH3, you have now a total of 4 electron groups. So we're still looking at the same part of the table where you have a total of 4 electron groups. Your electron geometry, it's tetrahedral for all of your possible combinations of bonding, non-bonding. So as long as you have 4 electron groups, electron geometry is tetrahedral. The one that is depending on how many of your 4 electron groups are bonding and how many are non-bonding is the molecular geometry. So out of your total number of 4 electron groups, 3 of them are bonding because it's forming a bond between the nitrogen and the 3 hydrogens. So you're looking at 3 bonding. And you have 1 lone pair of electrons, which is 1 non-bonding. So out of your 4, 3 are bonding, 1 is non-bonding. Electron geometry is still tetrahedron, which is the one that I have right there. But now your molecular geometry is not tetrahedron because you have 1 lone pair of electrons. Your molecular geometry is going to be trigonal pyramidal. For PF6, this one here, I have 6 electron groups around the central atom, always around the central atom. That's 6. Out of your 6 groups, all of them are bonding. There are no lone pairs of electrons around the central atom. You have lone pairs of electrons around F, but you're not looking at the terminal atoms to determine the shape. You're looking just at the central. So you have 6. I'm looking at this part of the table where you have a total number of 6 electron groups. Out of your 6 electron groups, all of them are bonding, 0 non-bonding, which means that both geometries are going to be exactly the same. And you have octahedral for both. I want to do this one. Your central atom is carbon, 1 electron group and 2 electron groups around carbon. 2 electron groups because even though it's a triple bond, your triple bond is counted as 1 electron group. If it's a double bond, your double bond is counted as 1 electron group. So around your carbon you have two electron groups. So I'm going to move the page. 2 electron groups, you have only one option. All of your electron groups are bonding. If you have a single bond and a triple bond, all of your electrons are bonding. Electron and molecular geometry for both, it's going to be linear, okay? 0 non-bonding, so both of them are linear. So to practice, do the Lewis structure for PCl3 and XeF4. So start by counting how many valence electrons you have in total for each one, which one is your central atom, forming a single bond between the central atom and your terminal atoms, completing the octet to your terminal atoms. If you have any electrons left after completing the octet in your terminal atoms, you need to add those electrons that you have left around the central one. Make sure that if you have something with more than 8 electrons, that element is in the third period or a period higher than the third one. Make sure that everything has 8 electrons with your taking into consideration your exceptions, the elements with less or with more, and make sure that you're using the total number of electrons that you're calculating for each one. Use your Lewis structure to predict the shape, both of them, the electron and the molecular geometry.